This lesson is going over solving rational inequalities. The steps are to first write as a single fraction. Second, determine the critical numbers. Third, test intervals on a number line. And fourth, write your answer in interval notation. Our critical numbers are the zeros, which are found by setting the numerator equal to 0, and undefined values found by setting the denominator equal to 0. Pause the video and write these down. For this first example, we already have the fraction, a single fraction on one side and 0 on the other. So we can start by finding our critical values, which we are going to first find any zeros. Now, when you're finding zeros, you're setting your equation equal to 0. But then you're going to multiply by the denominator so that you can actually work with this function. And when we do that, we get the reduction on the left-hand side and 0 on the right-hand side. So what you're really doing is you're just setting the numerator equal to 0 because the denominator is going to reduce to 0 by that multiplication anyways. So you might as well save time and not write it. So for zeros, we're going to just get x is -5. And then for undefined values, we set the denominator equal to 0. So we take that 4 minus x squared equals 0. And I can factor this with a difference of squares. Or I can add x squared to both sides and use the square root method because I do not have an x term, just an x squared. When I take the square root, I must remember positive or negative, and then the square root of 4 is 2. So then my values on the number line are going to be those zeros and undefined values. So I have a 0 at -5, and undefined at -2, and +2. Now, because this is where a function is undefined, it does not matter if the equation was, or if the inequality was less than or equal to, or just less than. Undefined values means that that function is undefined there. Whereas zeros, it can include 0 if it's saying equal to. So this one is less than or equal to, so I can include the 0. Then I'm going to test numbers in those intervals. Because it's less than or equal to 0, I can identify where that changes because above the x-axis, values are always positive. Below the x-axis, values are always negative. So on my number line, it's really just the x-axis, and I'm trying to identify where is the function positive or negative. So I can identify this inequality without actually graphing this. So I'm going to pick values to test. And the first interval is from -∞ to -5. So I'm going to pick -6. I know this is the only place that it's going to cross or touch the x-axis. So I know it's not going to cross through it before, or else that would have been a 0. So by testing -6, I'm going to take -6 plus 5 over 4 minus -6 squared. And I don't actually care about the values. And so because of that, I'm going to kind of backtrack and factor this first. So I'm looking at x plus 5 over 2 minus x 2 plus x. So then when I set x equal to -6, I get -6 plus 5 over 4 minus -6 squared, but I'm going to use the factored version, or the factored form, so I'm going to get 2 minus -6 times 2 plus -6. Now, the reason why I prefer the factored version is because I can identify the sign of the value, even though I don't care about the value. So -6 plus 5 is a negative number. 2 plus 6 is a positive number, and 2 plus a -6 is a negative number. So if I take a negative number and divide that by a positive times a negative, my overall value is positive. So I don't care what that value is, I just know that it's above the x-axis. Then I'm going to pick a number between -5 and -2. And again, because there was not a 0 or an undefined, I know that it can't cross over the x-axis. So it has to be doing the same thing in that entire interval. So I'm going to pick -3, just because that seems like it's going to be an easier value. So I'm going to plug in -3. So -3 plus 5 is a positive value. -3, so 2 minus -3, that's a positive value. And then 2 plus -3 is a negative value. So now I have a positive divided by a negative, which is negative. And then I'm going to do the same thing between -2 and 0, or -2 and 2. So I'm going to pick 0. And then I'm going to do the same thing between 2 and infinity. So I'm going to pick 3. You could pick 10 or 100. So when I input 0, I get a positive, because 0 plus 5, over 2 minus 0, just positive. And then 2 plus 0 is positive. So I have a positive divided by a positive, which is positive. So I know in that interval, it's going to be above the x-axis. And then testing +3, I get 3 plus 5 is positive, 2 minus 3 is negative, and then 2 plus 3 is positive. So I have a positive divided by a negative, which is negative. This helps me identify where is my function less than or equal to 0. So if I'm getting positive outputs, that's not less than or equal to 0, but -5 is less than or equal to 0, and anywhere underneath the x-axis is less than 0, and anything above the x-axis is not. But then I have this. So my answer, erase some of these lines a little bit, is those intervals that I put in yellow. So from -5, including -5, to -2, but not including -2, so we use a parenthesis, union 2 with a parenthesis to infinity, and then infinity has a parenthesis as well. And that is your solution. It is those intervals on the function that are going to give you negative outputs. Those are the x values you use to get negative outputs. That's what we found. For this example, we have to combine these to a single fraction. So what I'm going to do is get a common denominator. So I have this x minus 5, and then I'm subtracting 1 over x minus 1. So I'm going to multiply the x minus 5 fraction by x minus 1. And I'm going to multiply the x minus 1 fraction by x minus 5. Then I have a common denominator. Pay attention to your negative sign. So I'm going to change it to addition and put the negative up top in the numerator so that I can keep track of it better. So I'm going to distribute because I'm going to have to combine these numerators. So then I'm going to take the 2 and distribute it. So 2x minus 2. And then I'm subtracting I'm subtracting x and then adding 5. And that's all over the x minus 5, x minus 1. So then I can take the numerator and simplify this. Don't forget the greater than or equal to 0. So I end up with 2x minus x and negative 2 plus 5. So x plus 3 divided by x minus 5, x minus 1. And that's greater than or equal to 0. So I'm going to find my critical values. So the zeros, this is where you set your function equal to 0, but then you're going to multiply both sides by the denominator. So you're going to get x plus 3 over 1. And then on the other side, you multiplied it by 0, so the denominator just turns to 0. So our shortcut is to set the numerator equal to 0. 0 equals x plus 3. So then my 0 is x equals negative 3. Then we're going to set the denominator equal to 0 to find our undefined values, because that's where we're pretty much excluding those values. So undefined. So I'm going to set the x minus 5, x minus 1 equal to 0, and my undefined values are 5 and 1. So then I'm going to place those on my number line. So I have my 0 is negative 3, and then I have 1 and 5 for undefined values. Again, this is just a snapshot of the x-axis. Because this was equal to 0, I can include my 0. But I can never include my undefined values because those make the function undefined. It can never be equal to those numbers. So then I'm going to test my intervals to see where I can get values to make this statement true. So from negative infinity to negative 3, negative 3 to 1, 1 to 5, 5 to infinity. So let's do x is equal to negative 4. And then I'm going to use the factored version of this because I just care about the sign. I don't care about the actual value itself. So by inputting negative 4, I get negative 4 plus 3 is negative. And then that x minus 5 and x minus 1. So those are placeholders for the factors. So I get a negative and a negative. So negative times a negative is positive. So I have a negative divided by a positive, which is negative. So in that interval, it's always underneath the x-axis. Next, let's test 0. So when I have placeholders for those factors, when I input 0, I get 0 plus 3. So that's positive. And then 0 minus 5 is negative, and 0 minus 1 is negative. So I have a negative times a negative is a positive. So then I have a positive divided by a positive, which is positive, which means those values are always above the x-axis. And then let's do x is 2 and x is 6. You could do x is 10 if you wanted. So I have a positive, and then divide that by 2 minus 5 is negative, 2 minus 1 is positive. So I have a positive divided by a negative, which is negative. And then when I input 6, I get 6 plus 3 is positive, 6 minus 5 is negative, nope, positive. And then 6 minus 1 is positive. So I have a positive divided by positive, positive. So I'm looking for values where the function is greater than or equal to 0. So these are my positive values because I want outputs that are positive. And I can include my 0. So because I want positive values, including the 0, I'm going to do the positive intervals and my 0. Again, never including my undefined values. So then my solution is going to be -3, including -3 to 1, not including 1. Union 5, not including 5, to infinity. And that's my solution. For this problem, I have to get one of the sides to be 0. I typically put the right-hand side to be 0 just to kind of be consistent. So I'm going to subtract that 3 divided by x plus 1 on both sides, because then I end up with 0 on one of the sides. So I get 5 over x minus 3 minus 3 over x plus 1 is greater than 0. So then I can get a common denominator. So I'm going to multiply by x plus 1 over x plus 1 and x minus 3 over x minus 3. And I'm also going to keep track of that negative by changing it to a positive. So I'm adding a negative instead of subtracting. So I'm going to distribute the 5. I get 5x plus 5. And then I have the same denominator, x minus 3, x plus 1. So I can combine the numerators. So I'm subtracting 3x and adding 9. So I'm going to clean this up a little bit by combining like terms, and I get 2x plus 14 over x minus 3, x plus 1. And I'm even going to factor that 2 out of the numerator and do 2 times x plus 7 over okay, too many undos. X plus 7 over the x minus 3, x minus 1, or x plus 1. And that has to be greater than 0. So I'm going to draw my number line and kind of combine steps here. So remember, we set our numerator equal to 0 to find our zeros. The 2 is never going to be 0, but I'm going to get -7 as a 0. And then we set the denominator equal to 0 to find our undefined values. So I have a +3 and a -1. And then we never allow the function to be equal to our undefined values because it's undefined. And this specific one is not equal to 0, so I have to not include the 0 either. Then we're going to test intervals. So I'm going to test -8 to test that far interval. And then I'm going to do -2, 0, and 4. That's going to test all of my intervals. So a 2 is always positive. And then I'm going to have 2 different factors in the denominator. So when I input -8 plus 7, I'm going to get a negative value. And then -8 minus 3 is negative. -8 plus 1 is negative. And I end up with a negative divided by a positive, which means negative. When I do -2, I get x plus 7. So -2 plus 7 is positive. I can do some of these factors at the same time. So if I want to think about 0 plus 7, that's positive, and 4 plus 7 is positive. Then if I look at x minus 3, -2 minus 3 is negative. 0 minus 3 is negative. 4 minus 3 is positive. And then if I look at the x plus 1, -2 plus 1 is negative. 0 plus 1 is positive, and 4 plus 1 is positive. So then I can look at these. I have a positive divided by a positive is positive. A positive divided by a negative is negative. And a positive divided by a positive is positive. So I'm looking for where my values are greater than 0, because that's the side that I had. And so I want my positive values again. So it's this section and this section. So my solution is -7 to -1 union 3 to infinity. None of them being included. Now, if this problem had been slightly different, say it was those same values, I'm just going to rewrite the factored form because that's the one I can see easily. But then instead I want less than 0. Well, I already have all that information from the number line. So -7, -1, 3. And then my intervals were negative, positive, negative, positive. I never include my undefined values, but I sometimes include my 0. This one I'm not, because I just said less than, not less than or equal to. So if I'm asking for the values that are less than, that means I want the negative intervals, because those are less, negative values are less than 0. So then it would be this section and this section. So then by changing that part of the problem, if this was my problem instead, my answer would be -∞ to -7, union -1 to 3. And that would be my answer. And then if I went as far as to change it to include 0, then I fill in my 0 and I turn that to a bracket, and then that would be my answer. So it's fully dependent on the inequality sign as to which sections you're keeping and if you keep the 0 or not. And that is the lesson.